Okay, so here's a video for the second part of section 6.3, dimensional analysis. Now, these problems here are the more complicated ones because they're now converting between the customary units and metric or vice versa. Um, really, it doesn't matter which unit you use when you're doing these. You can do customary to metric or metric to customary. If you do it in the right spot, it's going to give you the same answer. So here's that sheet that I had in class that I printed off and handed out to you. Just another copy for me at home. So I'll be coming back to this as we go through each problem. Now the first problem the book does is, and I'm going to walk through these just so you have a little more idea of what they're doing. They want to convert 12 centimeters to inches. Okay, so they've got 1 inch is 2.54 centimeters, and they don't do the kind of the T-chart like we do. They use the fractional. They do it as fractions, but it's the same thing. They just don't write it out again in this way. So if you need to, I'll turn it into this when I do the problems myself. But when they go through them, they do this. So again, they have 12 centimeters. They're converting to inches. 1 inch is 2.54 centimeters. That's what they decided to use for their conversion. They could have also used that 1 centimeter is 0.394 inches. The only difference is, let's put this way. They could have used that 1 centimeter is 3.94 inches. The only difference is the fact that instead of this being 1 over 2.54, it would have been 0.394 over 2.54. Strike that. 0.394 inches over 1 centimeter. So they would sort of flip that. And so now it would still cancel off centimeters to inches. It just would be, instead of you dividing 12 by 2.54, we'd end up multiplying. See, I just swap those out. 0.394 inches. It'd be 12 times 0.394 inches. And as you can see here, they end up dividing. They end up dividing 12 by 2.54. Well, if I do 12 times 0.394, I get 4.728. They got 4.72. That rounds to 4.73 to the nearest hundredth, but it's close enough for what we're doing. So don't be worried about choosing the wrong conversion unit. As long as you choose one of them and put it in the right place, you're going to get the same answer. So hopefully that makes sense. Yeah. So the next example the book uses is 4 liters to quarts, 4 quarts to liters, excuse me. They use 1 quart is equal to 0.946 liters. So again, putting that in the chart form, 4 quarts over 1. Then I need to put 1 quart in the bottom so I can cancel off quarts and get 0.946 liters. And then they multiply through, and they end up getting 3.78 liters. So 4 quarts is approximately 3.78 liters. Okay, so let's look at some examples. We'll just do, 1 or 2 of these. We don't need to do all 3 of them. I just printed them out from the book. So let's say we do the first one. Actually, let's skip the first. We did plenty of miles to kilometer in class. So let's look at ounces to grams instead. So I want to convert ounces to grams. Now the first thing I need to do is I need to go back to my table and find something that converts ounces to grams. Now there are, by the book, 2 different metrics to do this. 1 ounce is 28.350 grams, or 1 gram is 0.035 ounces. It doesn't matter which one you choose. I don't know, just for the heck of it, I'll take this one here. 1 ounce is 28.350 grams. So 1 ounce equals 28.350 grams. So now when I go to set up my conversion, I know it's 12 ounces over 1. Okay. Luckily, I do have one that goes directly from ounces to grams, so I'm done now. As soon as I set this up, I'm finished. I want to cancel off ounces, so I need to put ounces in the denominator, and I want to keep grams at the end. And now, there we go. I've canceled off the units. So now it's just a matter of placing the conversion into the right spots. So 1 ounce is in the denominator, 28.350 grams. I know it's sloppy, but we get the idea. So 12 times 28.350 grams. Zoom that down a little bit there if you want a little bit bigger view on it. So yeah, 12 ounces is 28.350. So I'll pull up my calculator. What this is going to end up being is simply 12 times times 28.35 in the end. .350 technically, but 0.35 works. And we get 340.2. So 12 ounces is 340.2 grams. Okay, great. We did yards and meters in class, so we can skip ahead to the next example. The examples that are probably more difficult, honestly, are the ones that are the conversion for rates, like this one, that convert multiple units in the time in the denominator and the numerator. So, for instance, this example is from the book. We're going to convert centimeters per second. Oh, sorry. Here's the example they're talking about in the book. If I want to go back to that. So here we have this tortoise right here. Its top speed, a giant tortoise can travel about 900 feet per hour. So in this example, then we're going to convert 900 feet per hour, which is what they've got right here. Okay, 900 feet per hour into centimeters per second. So again, in class, the way you saw me do this was I wrote over to the side centimeters per second. I did underneath, I think, in notes, but off the side here. So my goal is to get from feet to centimeters, and then from hours to seconds. I've got to get to those 2 units. And once I get centimeters on top and seconds on bottom, I know I'm ready to start multiplying across and dividing. So as far as feet are concerned, my units are that I know 1 foot is 12 inches. And I have to use that because in my conversion, I don't have anything that converts feet to centimeters. I have feet to meters and meters to feet, but that's it. So I'm going to have to instead go through for feet. I have to go from feet to inches, and then I can go from inches to centimeters. So I go from 900 feet. 1 foot is 12 inches. 1 inch is 2.54 centimeters. So notice the first 2 steps, and again I'm going to draw the line through and kind of write it like we did in class with the vertical lines. 900 feet to 1 foot. Feet are gone. 1 foot is 12 inches. Okay. And then 1 inch is 2.54 centimeters. So put 1 inch, 2.54 centimeters. Inches cancel off. And now what's happened is I've got on top left over centimeters like I want it. And the last part, they did this a lot of times where it went from like hours to seconds. So 1 hour is 60 minutes, 1 minute is 60 seconds. So now I've got hours on bottom. Need to get rid of the hours on top. By doing that, 1 hour is 60 minutes. And then I need to get rid of minutes. So 1 minute is 60 seconds. Minutes and minutes cancel. So we get seconds, seconds. So the units are all this over this, but the units are centimeters on top, seconds on bottom. So again, they show the canceling of the units, and then they've multiplied across. 900 times 12 times 2.54 is 27,432. My mouse out of the way. And 1 times 1 times 1 times 60 times 60 is 3,600. And then when you divide that, you get 7.62 centimeters per second, which is not really a ton of speed. Okay. So here is then my example that I can I'm going to work through for this complex rate problem. So at a recent Winter Olympics, USA short track speed skater Apollo Ono won a gold medal by skating about 12 meters per second. There we go. At about 12 meters per second. Rounded to the nearest hundredth, how many miles per hour is this? Okay. So we have to start off with, in this problem, I have 12 meters per second. So I'd write 12 over here, meters. Just draw the line out. 1 second. But I want this to be instead of meters, I want it to be miles per hour. So I need to figure out, how do I convert meters to miles? Well, we go to our units. I know 1 mile is 5,280 feet. Now that's on the sheet I gave you in class, but it was in the inside cover of the book, or you have it memorized. So I can get to, so miles can give me to feet. That's a conversion we already know. So the real key is, can I get from meters to feet? And I can. I have two different ways to do that. I can say that 1 foot is 3.05 meters, or 1 meter is 3.279 feet. It doesn't matter which. I used this one here earlier on, so let's go with this one. So 1 meter is 3.279 feet. Excuse me, sorry. So now I'm ready to go from meters to miles. Well, I can go from meters to feet, so I'll do that first. So 1 meter is the same as 3.279 feet. Meters cancel. Now the next thing is, I know 1 mile is equivalent to 5,280 feet. And now feet cancel there. And I get 12 times 3.7. I mean, that's what I'll have on top. But now I've got left over on top miles, which is what I want. Now my goal is to get from seconds to hours. Well, I got to build up then in units, so to speak. Well, I know 60 seconds is equal to 1 minute. And 60 minutes is equal to 1 hour. So now we can just fill in our time. Okay. So seconds, that means I need to have seconds on top, and seconds is equivalent to minutes. So 60 seconds is 1 minute. Now seconds cancel. And now I've gotten to minutes, but I want to get to hours, so minutes has to go on top, hours has to go on bottom. 60 minutes is 1 hour. And now minutes cancel. And I'm left on bottom with hours. So I can multiply across on top, multiply across on bottom, and then divide, and we're good to go. So I'm going to pull up my calculator real quick. There we go. So I know on top I'm going to have 12 times 3.279 times 1, which I can ignore, but times 60 times 60 for the 60 seconds and 60 minutes. And that gets me a pretty good sized number. Gets me 141,652.8 technically miles. And then the leftover part is going to be to multiply the denominator. Well, that's just 1 times 5,280 times 1 times 1. So 5,280. Technically it's in hours. So now it's just, my job is just to divide that by 5,280. And that gets me 26.83 approximately. Let's use the approximate. Yeah, so about 26.83 miles per hour. So again, just a little extra. I know it's kind of long, these two videos are, but hopefully this gets you enough to get you through this section. If not, come in for help or ask questions in class when we go through it.